SMB in a chewable size. So this is something I've been working on for a while, talking to a few people about, pushing the idea. I'm bringing it to a presentation now to give people a chance to throw things at me, which is exactly what I want, because that's involvement, right? Okay. SMB in a chewable size, defining a low-level API. I'll do a quick introduction so you know who, and for the few of you who don't know who I am. I've been doing these conferences for years now, so I'm kind of annoying to a lot of people. This event marks 20 years with the Samba team. 20 years ago at the precursor to this event, the CIFS conference, Jeremy Allison said, all right, Chris, all right, you can be on the team. Oh, God. And so I was on the Samba team. I currently work for WekaIO, which is an Israeli startup with offices here in San Jose, and of course the head development office in Minnesota. We'll get to that in a minute. But I'm presenting as me, as part of the Samba team, I guess, but mostly as me. So the opinions expressed, you know the rest. The monster in the closet and I do tend to get along, though. We agree on a lot of things, so maybe these opinions and ideas are the same. I live in Minnesota. Yes, we like it there. That's a lake behind us, just so you're aware. And pardon? A solid state lake, yes. That is a solid state lake. Very good. I like that. Yeah, when it gets really cold in the middle of winter in Minnesota, what do? We go north. That's what we do. By the way, this image on this page here I was telling folks here, it was the third place loser in last year's, hey, yeah, I remember Windows XP desktop background photo contest. Okay, so that was a big deal. Anyway, background on SMB. The reason I'm doing this, and not that, there we go. The reason I'm doing this, whoops, I have been talking to a couple people here at the conference who are like, I'm here to figure out what SMB is all about. Okay, so I'm adding a little bit of this in. Many of you I recognize will look at it and say, okay, so I'll try to get through it. But your basic your basic storage taxonomy, you have blocks, you have files, you have object store, right? These are the things we talk about these days. Subject to change as we invent new ways of thinking about things. Not necessarily new ways of doing things, just thinking about the things we do. Obviously, whichever one of those types of thing, is your preference, is the best one there is. Everything else is garbage. But I work in the file space. I have been, actually, I said I was with the Samba team 20 years, but I started with SMB in the 80s. It's the first time I started working with SMB protocol. And I've done other things, like ice skating once. But mostly, SMB has been at the core of what I've been doing for a long time now. The two predominant network file protocols are NFS and SMB. Some would argue that SMB is more popular. Some would argue that NFS is more open. I would agree on perhaps both counts. But those are the two. Many others, Apple File Protocol, Banyan Vines, Novell NetWare, going back. There are a lot of different file protocols out there. Andrew File System is still running in a lot of places. But those are the two primary ones these days. What SMB presents are things called shares. That's the exported unit. If you're familiar with NFS, a share is an export. Same basic idea. Under that, there are directories. In the directories, there are files. There are a few other objects in the file system, but those are the primary things we talk about. And it was a network extension that goes all the way back to MS-DOS. The first SMB was created by IBM for PC-DOS, not MS-DOS, but PC-DOS. It was ported to MS-DOS, and then it was ported to OS/2, and then it was ported from there to Windows NT. And the Windows NT port is still the one that if you're running SMB1, it's still the one that you're using today. It's still that same code base. It's been updated and changed over the years, but that's what it is. So 3 decades, more than 3 decades we've had this stuff with us. SMB also carries system calls. One of the reasons for creating SMB2 is that it got rid of all of the DOS and OS2 system calls that were being carried on top of SMB. Name pipes, remote procedure call, a lot of things are carried on top of SMB. It is infrastructure in a Windows networking environment. And that's what it says. Look at that. SMB is infrastructure. I'm ahead of myself. Think of it this way. You got TCP. You know, TCP is the thing we use. We use TCP. But now you add scalability to that. You add authentication to that. You add signing and sealing, which are, you know, signing means, yes, it really came from where it said it came from, and sealing is, I've encrypted it, nobody else can see it until it gets to you. And make that your network connection, and you put that on top of TCP, it's not hard to see why an organization like Microsoft would start using this as a transport. It has all the same capabilities of TCP plus all the features that you might want for security and reliability and scalability, because they can do a variety of things with scalability. We've already mentioned RPC. There's also something called RSVD. I was just talking to people in the hallway about. RSVD is used for Hyper-V, remote shared virtual disk, or something like that. I think that's right. WekaIO. This was discussed publicly, so I know I can share it, but a few years ago I was told, shh, don't tell, that they're using SMB internally in their clustering systems. So it's a transport. It's a forwax. It's a dessert topping. It's a transport. You know, it's all these wonderful things. For those who don't really know the difference between SMB1, SMB2, and SMB3, how many people don't really familiar with the differences? I got one. Okay, I got maybe two. Okay, good. SMB1 is the new name for the original one. Okay? So SMB1, so I'm not wasting everybody's time. SMB1 is the new name for the original SMB that started with IBM and continued through Windows NT and is still with us today, although nowadays when you get a new Windows system, it is turned off. They disable it now. SMB1 is the original. It was actually created by a guy named Barry Feigenbaum at IBM in the 1980s. It was originally called the BAF protocol, the Barry A. Feigenbaum protocol. Then it got renamed to SMB by IBM. There was a lot of work done on it by a variety of companies, including Microsoft. 3Com, IBM, Intel, all these companies participated in the development, the early development of SMB. All right. Again, it was originally for PC-DOS, MS-DOS, and then for OS2. And if you track, as I have had to do, if you track the history of this protocol, you can see in each revision how a new version of each of these operating systems would come out, and with it, a new version of SMB with new features. All right, so Landman 1, Landman 2, Landman, you know, all these different Landman versions represented different versions of operating systems that were coming out. And when a new version of OS2 came out, they would also come up with a new version for DOS that you would then load in so that that DOS version could talk to that OS2 version more efficiently and effectively. All right? Dialects tend to come out with operating system releases. That's still true today. The final dialect of SMB1 is the version that was ported to Windows NT from OS2. They gave it the name, a funny name, NTLM, NT Land Manager 0.12. And that is still the string that is sent on the wire when they negotiate, even today on a Windows. You know, if you turn on SMB1 on a modern 2016 machine or something, if you turn on SMB1 and get it running, that's the negotiation string. They still use that. There have been changes to the protocol since the day it was ported from OS2, but it's still given the same dialect name. With Windows Vista, remember that? With Windows Vista, they quietly snuck in a new SMB. This was a whole new protocol. It's different, not the same. You could negotiate up from SMB1 to SMB2, but it was a different protocol. All right? It was a fourth the size in terms of command space. That's a big deal. It means a lot less work for programmers. Got rid of all the DOS and OS2 stuff. Just dumped it. Straight Windows. Right? Very similar design, however. They went back to basics. And so it was familiar to people like me. You know, I looked at it and said, oh, I know what that is. Right? Silently negotiated. They would just you know, a Vista machine talking to a Vista machine would simply say, we're going to talk this new language. And you wouldn't know it if you were running as a user. You wouldn't notice, which was kind of interesting. And then along came SMB3. Whole new protocol. No, it's not. Actually, SMB3 is a marketing upgrade. SMB3 came out originally as SMB2.2. All right, it was just a dialect, and it still is just a dialect. It is exactly the same as SMB2, except it's got more features. Okay? The message structures are the same, the commands are the same, the parsing that you do, the work you do under the hood to make this work is the same. But it adds the ability to use RDMA for communication. It adds the ability to use multiple Ethernet connections, multiple TCP connections for client-to-server communication. And it adds something called persistent handles, where if one machine goes down, you reconnect to another, and the user doesn't even notice. All right? So it adds a lot of really nice features. And as an upshot of all that, now that we're in this SMB3 era, SMB1 is dead. Microsoft has said, done. Cut it off. Turn it off. Don't do it. It's dead. Go away. No more. Let it die, please. All right? So SMB1, pardon? And laptop stickers that say friends don't let friends. Yes. Yeah, so you know, if you know the right people at Microsoft, you can get a sticker that says friends don't let friends use SMB1. Okay? Microsoft is very serious about that, and the rest of us out, you know, I'm a Samba team, I kind of go, yeah, it's about time. It's about time for that. Okay, here's another term. Ready? Woo! CIFS. Who remembers the term CIFS? CIFS is deader. Okay, so CIFS was originally Common Internet File System. That was another marketing upgrade. What happened was that in the 90s, Sun came up with Web NFS, and everybody thought, ooh, that's going to be the next big thing. They were right, weren't they? You've all heard of Web NFS, right? Web NFS. Okay, so Microsoft was like, what do we do? What do we do? What do we do? What do we have in the closet? Oh, there's a pig. Let's put some lipstick on it. Okay. And they took SMB out of their closet, and they renamed it CIFS, and they brought it to the IETF for standardization. That didn't work very well. And the term CIFS meant the next version of SMB. We're going to have a next version of SMB. And then there were lawsuits. The US government, the European Union sued Microsoft, and the lawyers redefined CIFS to mean all the old stuff. Wait, what? It meant SMB1, what we now call SMB1. So that term, Microsoft a few years ago said, okay, we're done with that. That didn't work. Get rid of it. So that term is dead. If your marketing material says, we support CIFS, go rewrite your marketing material. Okay? All right. And how standard is SMB? SMB is very pervasive, but it's not standard. There's no standards body that says this is what SMB is. Here are the published, official standard body specs. The only thing you get is you get Microsoft specs. All right? SMB1 was not documented in any way, publicly or otherwise, for years. They didn't even have documentation for it. And when they released the CIFS specs, when they submitted those to the IETF in the mid-90s, they were wrong. There were a lot of errors in those docs. All right? I know that SMB1 was undocumented for years because 10 years ago, this guy in the light blue shirt over here said, hey, come work for Microsoft for a while. We need somebody to write the SMB1 docs. And that's, that's how I got my in over my head. Anyway, it's not standard. There are docs. There is a necessity for backward compatibility. There are now docs for the newer stuff, And all of this is entwined with Microsoft's internal infrastructure, so they have their own needs for keeping this stable, right? So even though it's not a standard, we can look at SMB and say, it's going to stick around for a while and it's going to be pretty much what we recognize today. Even if they come up with a new one, SMB4, and they have a new protocol, okay, the old stuff's going to be there for a while until the new one takes hold. And we'll have time to hopefully catch up. Okay, so that was our recap. Here's where I want you to start paying attention. This is where I get interesting, I hope. Anyway, all right, so SMB. Let's talk about the SMB protocol stack. Everything's got a protocol stack. If it's in computers, it's got a protocol stack. At the bottom layer of the SMB protocol stack, we have the syntax, the basic what goes on the wire, what comes off the wire. At the top, we have the semantics. What does it all mean? What in a deep and cosmic way does it mean? All right? And this gets really interesting because I've spent this week talking to a variety of different vendors who are doing different types of work. I work on Samba. We cover that whole thing. We start with the syntax. We take the stuff off the wire. We break it down. We convert it into something more POSIX-y so that we can think of it in our own terms. And then we execute POSIX commands to do the job we need to have done. And then we take all of that and translate it all the way back to Windows, put it back on the wire, send it back across. And that's how we do Samba. That's why Samba is big. There are other companies that are here, there are other organizations, companies in particular, that are here that write a very thin layer. They cover about, about there. Because their goal is to sell you an SMB protocol engine that you then integrate into your product, that you specifically take and integrate into the way you want to do things, right? And you don't go all the way up to, full translation to POSIX and then back down to the file system. And you can shortcut that directly to your own system, whatever that is. All right? So that protocol stack really is something you can divide up into layers, and you can say that those layers could be separated and connected by standard programming interfaces. Here's the border of my layer. Here's how I define it. These functions, these structures, these operations, this is what we're going to do at this layer, at this division of the layer. Kind of like how the OSI stack, everybody learned the OSI stack back in the day, and every layer had an API defining it so that you knew exactly how the next layer would talk to it, right? And we can leverage this messaging hierarchy to isolate the parsing and packing. The basic, here's the data, let's put it on the wire. Here's the stuff off the wire, let's break it up so we can use it. We can isolate that. We can handle some of the basic syntax errors, some of the bottom level stuff fairly straightforwardly. A lot of syntax errors on the wire. The response that the Microsoft documentation says to give is drop the connection. We can do that. That's easy enough. And there's base level state. There's stuff at the bottom layer when you first make a connection, even before you make a connection. What dialects do I support? What capabilities do I support? Before a connection even occurs, you can establish that state for this environment. And so what I'm proposing, what I'm talking to people about is that we could create a standard low-level SMB2 messaging API. All right? So if we create that API, if we create that level, what can we do with that? And that's what I think gets interesting. It could be implemented as a library. It could be implemented as a device of some sort, a pseudo device, let's call it. Or both, a combination. That's what I have in mind. And once you've done that, where can we put that? It could be built into a pseudo device on a system, FreeBSD, Linux, whatever, or using that same set of calls, the way you do with a socket, for example, you could put it onto an offload engine, into a card, into some sort of platform environment. You can hide the differences between different transports, like TCP, RDMA. They were talking about QUIC the other day. It's a new transport they're working on. Well, we can hide that. We can even hide multi-channel. We could mux demux at a lower level. We can also offload all that encryption for signing and encrypting the data going back and forth. All the cryptography could be put on a card because you're handing off to some other device to do this work. Okay? So if we do this right, and this is where it gets fun, we should be able to separate the semantic from the syntactic layers. We can mix and match stack components. And we can gain performance. So you develop your higher level SMB engine, your SMB stack, to run on software that you've written or that you've got from the open source community or some other environment. And then you sell that, let's say, or you put it in your product and you sell your product, and somebody says, I want it faster. Okay, well, let's put in an accelerator card that has this built into it, and now it can be faster. Okay, now it can go faster because we're offloading all that. All right? One of the things that makes this nice and easy, hi documentation person, one of the things that makes this easy is that Microsoft has some very strict structures for the documentation they produce. A lot of the organization of their documentation came from legal, the legal issues that they were finishing up. And so there are, there are sections in the documentation that are specifically syntax. Section 2 of the SMB2 document is about syntax. Section 3 combines semantics with an actual state machine. There's a full state machine described in there. And it's described in layers, so you can decide this is stuff that could be put into a standard interface, and this is stuff that is per implementation, we're not going to touch it. Okay, so nothing I'm about to suggest is carved in stone, particularly the names of functions, because as I looked at them today when I was going over my slides, I thought, those are really lousy names. I think we could do better. But the idea is, for me, you would open a handle to a pseudo device. I also want stacking capability. I want to be able to merge things. So I have another command here, SMB create, I called it. I'll give it a better name maybe. Bind or something like that, where you would have a regular device like an Ethernet, like a socket. That's what I mean. And then you'd bind that to a library and create the pseudo device actively where you are. I want to be able to do stacking. So for example, if somebody has a library out there and they've implemented everything through SMB 3.0.2, and I really want to run 3.11, I want to be able to stack the additional decoding on top of the existing library, and I want to be able to merge those two so I can get the additional parsing done. And then I want it to be hidden from whatever's above that that is going to be actually using that stack. A close would simply close whatever I have created in these other two. Obviously, we need to be able to do something equivalent to a connect. Hi, I'm a client. I'm using this stack. I want to talk to a server. I don't know if the server is using a similar stack or not, but I want to talk to the server. So I want to connect. I'm a server. I want to listen for these connections. I need something like an accept, something that lets me receive one of these connections coming in. Sending and receiving messages. These would be sending and receiving data structures. So you send a data structure. The actual marshalling of the data structure, taking all the bits and bytes from that data structure and putting them into wire format is hidden from you. You don't have to worry about it. Done, okay? On a receive, you get a data structure. You don't get the raw packet. I think this interface should allow for receiving raw packets. Hey, if you don't know how to handle it, give me the raw packet and I'll do it. But that's what I envision, at this point. Of course, that also means we need something equivalent to select or poll or both so that you can listen for messages coming in and you know when they're there. Set up, get opt. The idea is to be able to set parameters on the connection. Here's an example. The authentication happens at the high level, let's say. I think that's a good place for it. So the authentication happens at the high level. That means the high level is the level that gets the session key. This is the encryption key that's used to make sure everything is signed properly and sealed properly as it goes over the wire. You have to tell the lower level what the session key is. Here's the session key on this session. You associate it with a session. Right? So you have to be able to set options like that. You may have to set flags for a particular message going out. That should actually happen in the send and receive. But you may have to set options on a connection as you're running the connection. As things are happening, you may need to make changes. Updates, the re-authentication step, things like that. Pardon? Credentials. Right. So you want to share that state. You're at the higher level. You've collected state, credentials, whatever, and you say, I need to share these credentials with the lower level, and that's where these come in. Okay. This should be a win. I think doing this would be a win. I think it'd be a win for open source and commercial implementations. I think that, for example, to build this stack on BSD, on Linux, and then to build on top of that the actual implementation you want to use, that gives you a lot of flexibility. Because again, you've got a default, de facto, available implementation running on your system. Cool. I want more speed. Okay, I'm going to use a card that has an acceleration engine that can do this. Plug it in, off it goes. Okay? Cards, platform, device driver developers, all these people are in a position where they can, this is something to build, worth building, that can be now leveraged. I've talked to a couple of commercial SMB providers, and they're like, if we had a standard API, that would be really cool because then we could sell our implementation for embedded systems or for this or for that or for whatever, and we have now a product that we can sell, and the rest of it can be a separate piece. And a lot of the vendors are happy with that layering anyway because they don't know what their customers are going to be trying to communicate with. What's the file system? What's the environment? Is it a database? Is it something else? We have people trying to use SMB to talk to a variety of strange things. So having that separation, having a standard, just a standard layer where everybody knows what to expect, could be I believe that would be a win for everybody. So what we need to create that standard would be a rough draft spec from which to start. And I have some commitment from one of the vendors, at least, to say, okay, well, I've got this set of APIs that are already used. We'll use that as a starting point. I've got some code myself that I've been working on where we can say, okay, well, I want to have, this is what I'm trying to do, so let's see how this code works. Gives us a rough draft spec to start from. Going to need a committee. I've talked to my friend SW here about this. Probably here in SNIA because this is the right place to do this work. Reference implementation. That's something the SNIA likes to have. And an organization to provide structure and support. Well, I just said SNIA how many times? And that is pretty much what I'm aiming for here. So I'm going to say, talk to me. What are your questions? What are your thoughts? Am I nuts? I know that, but what would you like to know, particularly about SMB and how we could do this? Come on.
How would you imagine the implementation?
Say again?
How would you imagine the implementation?
How would the reference implementation look? Well, I started by giving some examples of what the API might contain. Again, there's a lot of detail work to be done there. Again, I want it stackable. Rafael here is familiar with the Samba VFS module system, where you can stack virtual file system modules and they can speak directly to the underlying file system in ways that are specific to the underlying system. I have the same idea here. You want to be able to stack a few things to make adjustments and changes, right?
This could be something that can run on an average Linux distro.
So, right, and then the idea would be to run the baseline on an average Linux distro, FreeBSD. Those would be, example platforms. That would work. I would hope that people at Microsoft might find some interest somewhere down the line, because I could see, especially in the Azure space, that being able to offload the SMB processing would be a viable thing to do. One of the things I've started on, I've only gotten a short way with this. Anybody who here is familiar with the TON device? Anybody know what a TON device? I got a couple of people, TON? Okay, so TON is a tunnel. And it's an interesting thing because it's sort of like TCP in user space. It's sort of like the Fuse file system, where you can write a file system as a program and then it pumps through the kernel and back. TON is very similar. You can create a TON device. It just appears as a device, like an Ethernet port. It appears, and when you send a TCP message through it, it actually comes out to the software you've written, and you can parse that or put it back together or whatever else. So one of my thoughts as a proof of concept on this, one of the things I'm working toward, is what would happen if I did multi-channel, SMB multi-channel, multiple Ethernet ports, right? And I did SMB multi-channel across those Ethernet ports and merged them and created a single TCP stream through the TON device. Samba could actually run against that now and would never have to know that there's multi-channel going on. All right? So that is how I've started writing that code just to see if I could make it go. And we will see if I can make it go. So this is where I'm going to learn what mistakes I'm making in my assumptions here, but because there always are. But you have to have the practical experience to know what the API really should give you, what it should offer to you. Okay. What else? I thought there were another. Anybody else with questions or ideas or comments or yeah?
Basing it on Samba code or something completely fresh?
It would be pretty much fresh. It could be. What my intention would be is that if my code is viable, if my code merges with other people's code, whatever else, we would release it under whatever the SNIA was interested in to use as a reference implementation, right? Okay, so I got an approval on that, I think. The idea would be that you could use that reference code to build your own. And that means it would have to be under a license that was adaptable. So if the Samba team were to come along and say, we like this, but we want it under the GPL v3, they could relicense it under the GPL v3 and take it away and do that. But the original code would still be there under the SNIA license to make sure that somebody else could come along and say, but we want it under a BSD license, right? You're welcome. All right. Yeah, I'm open. What I want is I want code that is usable, right?
That could effectively mean implementing an equivalent of SMB device, essentially.
Yeah. Actually, my original name for this was SMB dev, right? So you'd open an SMB dev, probably kind of some sort of socket thing. I'm opening this SMB dev to behave this way. I'm opening it to behave that way. You know.
Very close to the discussion we've had with June about doing this on devices, essentially.
Right. So one of the things we talked about is using Raspberry Pis to test this out. You know. Licensing ideas. Boy, what could I do with this? Does this have any impact on NVMe? What can we do with it? There was a presentation earlier this week where they talked about using NVMe to offload things to FPGAs. And if those FPGAs, it came to my mind, if those FPGAs were connected to the network somehow, then now you have a protocol engine. Boom, done. Right? So. Yeah. It's a tow card. It's a offload engine card. But the offload, well, I've been talking to some of the vendors. The offload engines now are, well, we used to do it with this and this, but now it's so easy to just put an ARM chip on there and a chunk of memory. And I'm like, okay, well. So that's what they're doing. They got an ARM chip, a chunk of memory, a little bit of flash, and boom, you know, you've got something. But again, what good is it if you don't have an API that you can count on to build on top of, right? So, and honestly, I'm going to need help hammering out what the details of that API are. I've got some ideas. I've got some, you know, I'm going to try some things. I'm going to make it go. But I will inevitably do something that won't work for somebody. So I need to know from somebody, whoever they are, what it is that they need to have work. Right? That's how a good standard comes to be. Okay, I'm done. Thank you.